Good day, grade 11 chemistry students. What we're doing today is we're learning about quantities again, same learning goal, but now we're going to learn about something called, we're going to learn how to convert to atomic mass. And what we're going to focus on today is molar mass. Okay, that's what we're referring to atomic mass as. We are talking about molar mass, how to use it, what it is. Okay, so what we're going to do is we're going to start with an analogy because it's going to help us understand molar mass. Okay, so I'm going to start with this question. How many pennies are in the jar? How many pennies in the jar? So the question is, can you do it without counting them? Okay, I want you to make an assumption. Think for a moment, how could we count them without actually pulling them one by one? Because that would take a while. Is there an easier way? Well, the answer is yes, there is an easier way. Let's assume that we just weighed the whole jar. We found the mass of the jar. If you did that, you would be able to calculate how many pennies there are if you knew how much a penny weighed. Okay? So if you knew that one penny was equal to 10 grams, and you knew the mass of the jar was, I know, like 4,000 grams, then you would know that you have 400 pennies, correct? Well, that's exactly right. It's easier to weigh things with mass. So would you know how to weigh it if, for example, if you had 100 pennies, you knew the weight of 100 pennies? Could you do the calculation just as easily? So let's say that you had 100 pennies equal 1 gram. Would you be able to calculate it? Well, I think you still would. And let's talk about how this very idea of the mass of a penny is equal to molar mass. Okay, to do this part of your activity, pause the video, get your periodic table. It will not work if you don't get your periodic table, and you won't get a lot out of it. So just make sure you get your periodic table now, and we'll walk through it right now. No cheating, get your periodic table. Okay, so turns out that carbon has a molar mass of 12 grams per 1 mole. Okay, take a look at your periodic table, try and figure out where this molar mass is coming from. Sucrose has a molar mass of 180.16 grams per mole. Okay, look at your periodic table, see if you can figure it out. Carbon dioxide has a molar mass of 44.02 grams per mole. Methane has a molar mass of 16.05 grams per mole. And oxygen has a molar mass of 32 grams per mole. Pause it, see if you can figure out what's going on. And hydrogen has a molar mass of 2.02 grams per mole. Well, where does this number come from? Well, if you figured it out, you will understand that the molar mass comes from the atomic mass of a substance. If we zoom in on hydrogen, it will have a molar mass of 1.01. If we zoom in on oxygen, it has a molar mass of 16. So you add them together. So for example, water weighs 18 grams per mole, because it's made up of 2 hydrogens, so 1 plus 1 is 2, plus an oxygen, which is 16. So altogether, it weighs 18 grams per mole. How does this deal with our penny example? Well, basically, if we need to count atoms, what we can do is we can count them just by weighing them, because we actually know how much the atoms weigh. Now, we don't know how much, when we do molar mass, it's actually grams per mole of a substance. So if we ever need to find the molar mass, all we do is we look at the molar mass on the periodic table. I'll explain how we found this in class tomorrow, but it is a little bit more difficult to explain, so we'll talk about it tomorrow. But if you ever need to find a molar mass, all you're doing is you're looking at the atomic mass, and the units that are equal to are grams per mole. So we define molar mass as the mass per mole of a substance. The units that we use to measure are grams per mole. That's how we show the units, G over moles, okay? The equation that we're going to use for it, the letters that we're going to use to represent it, the textbook uses a capital M. I've seen it as 2 capital M's, and that's how we're going to do it in this class, 2 capital M's. Sometimes, though, the textbook will just use 1 capital M. We're going to use 2 capital M's, and the equation that we're going to use is mass, which is grams, divided by N, which is moles, M-O-L. So our units for molar mass are grams per mole. How can we use molar mass? Well, we know molar mass is equal to the AMU, or atomic mass units. In other words, this statement right here means the number from the periodic table is how we get the molar mass. Well, how can we use molar mass? Well, molar mass allows us to convert between mass and moles. Mass is in grams, and moles is amount of things, okay? So little m is how we represent that, and moles is represented by little n. But it's a quantity, so we can represent things. Remember at the beginning of this lesson I said you have a certain amount of pennies. How can you figure it out? Well, if you know the mass, you can figure out how many pennies you have. Well, this is the same deal. It allows us, if we know the mass of a substance, we can find how many moles of a substance is, and a mole is a quantity. So we have a question here. It says, how many grams are there in 10 moles of carbon? Well, let's write down what we know. We know N equals 10 moles, and we want to find mass, which is going to be in grams. We don't know what that is yet. But we want to be able to find that. Well, if we take a look at our dummy equation here, we have molar mass equals mass over moles. This is our triangle here we can use. And we know my mass. I want to find my moles. That means I need to find my molar mass. Well, we can find the molar mass of any substance just by looking on the periodic table. So if we look at our periodic table, we see carbon has a molar mass of 12.01 grams per mole. So what we would do next is we would say, okay, how many grams are there? Well, mass, if you cover up this part of your triangle, molar mass is right beside N. So that means mass equals molar mass times moles, okay? And we can show that or vice versa. It doesn't really matter which one goes first. So what we're going to do is we're going to find our mass, and we take our molar mass, 12.01 grams. I'm going to put that over 1 mole. That's the same as writing this unit like this. And we multiply by 10, and the answer is 120.1 grams. So if 1 mole weighs 12 grams, it makes sense that 10 moles is going to weigh 10 times as much. But take a look, guys. I have my moles are canceling out. Unit cancellation works. I know I did it correct. This is my final mass. We have another question here. It says, how many grams are there in 10 moles of carbon dioxide? Now, I know that I've got little n, which is equal to 10 moles, and I know I have a mass that I want to find. And if we look at our triangle again, molar mass equals mass over moles. I have my moles, check. I have my mass. I want to find that. I need my molar mass. So what molar mass of what's our substance here? Well, it's CO2. So I need the molar mass of CO2. And that means that I have the molar mass of 1 carbon there plus 2 oxygens. Okay, that's actually an O there. That's not 20. That's 2 O's because there's 2 O's right there. So carbon plus 2 O's. So looking at the periodic table, we have a molar mass of, I always round to 2 decimal places, folks. That's always important, 12.01. And oxygen, it's 15.999, 3 nines there. So that rounds to 16 grams per mole. So what we're going to do is just substitute that into our, so what I've done that is I have CO2. So I'm going to multiply that. I have 12 from the carbon and 16 from the oxygen. But remember, we have 2 of them. So I have to multiply this all by 2. That's going to be 32 grams per mole plus 12.01. The answer is going to be 44.01 grams per mole. So if I have 1 mole of carbon dioxide, it weighs 44 grams. Now to find M, it's going to say here that we have to take our mass, and multiply our molar mass times our moles. We set it up just like we did previously and multiply it together. So 44 grams per mole is my molar mass, and I have 10 moles. Therefore, if 1 mole weighs 44 grams, 10 moles is going to weigh 440.1 grams. Moles cancels out. There we go. It makes sense. So we found my mass just right from my periodic table. Molar mass multiplied together, get our answer. Let's do one more very quickly. Okay, our next question is how many moles, N equals question mark, because remember N equals moles, and we want to know are there in 135 grams of ammonium sulfate. So what I'm going to do first is I know that my mass is 135 grams. I know my substance is ammonium sulfate, so go to my periodic table. NH4 has a positive charge, sulfate has a 2 negative charge, so it's NH4 bracket 2 SO4. And we have 135 grams of that. We want to know how many moles we have. Well, if we look at our dummy triangle here quickly, molar mass equals mass over moles. We have our mass. We want to find our moles. That means we need our molar mass first. So I need my molar mass of this substance. That's a little bit difficult. Let's quickly look at it and let's determine what atoms we have present. Well, I have 2 nitrogens because that multiplies in there, plus 8 hydrogens, plus 1 sulfur, plus 4 oxygens. Okay, that's an O, that's not a 0. So what we're going to do is I'm just going to fill in my values from my periodic table for nitrogen, hydrogen, sulfur, oxygen. I'm just looking at the atomic masses. Okay, so I filled in my molar masses for nitrogen, hydrogen, sulfur, and oxygen. We just multiplied 2 times that number, plus 8, plus 32, and then plus 4 times 16. I'll just do that math quickly. We'll get an answer for our molar mass. So the answer I got was 132.16 grams per mole. So we know if we have 132.16 grams, we have 1 mole. Well, let's take a look. We have 135 grams. That means we should have slightly more than 1 mole. Agree, everybody? Because that's 1 mole. That's a little bit more, so therefore it's got to be a little bit more than 1 mole. Let's look at our equation. To find N, M is over MM, so that means N is going to equal mass divided by molar mass. If you're not in my science class, chemistry students, don't use big MM. Your teacher may prefer for you to just use 1 capital M. But if you are in my science class, obviously, you're going to use the 2 capital MMs there. So we just substitute our values in. We have N, which we're trying to find, which is moles. We have 135 grams. This was given to me in the question. We found the molar mass, which we're going to divide by. And this can also be shown as the following. Because this is the fraction here, this is a whole number divided by a fraction, you can multiply by the reciprocal. And if you take a look, our units will cancel out. We get our units in our moles. Calculate that out. 135 divided by 132.16. And the answer is 1.02 moles. So that was right what we estimated because we knew that the mass was 135. The molar mass is 132, so therefore we have around 1 mole. For tomorrow's class, please try the following problem. It's actually a 2-part question. I want for sure for you to answer this. How many moles are in 100 grams of water? If you can answer that, fantastic. I'd like to see it before the beginning of class. And finally, if you are feeling really ambitious, if you'd like to be a 95% student or above, and without me even teaching you yet, how many molecules are in 100 grams of water? So in this last question, I'm not asking how many, what's the moles of it. I'm asking how many molecules you have. So it's a 2-step process. See if you can do it. But definitely try and answer the top question. Thanks for listening. Enjoy your day. See you